Alright, we're back. As soon as you start to get the hang of these, I strongly recommend that you pause and work out the problem and then check it with me. So I'll continue doing these. What we notice on 4 is that the subtraction is first. So I like these to be in standard form. So I'm going to write the y squared first. Since the 16 is negative, I write it as subtraction. This is a difference of squares, which gives me y plus 4 and y minus 4. Number 5, 100 is a perfect square, 81 is a perfect square, y squared is a perfect square. So we have a difference of squares. We factor to square root of the first. So square root of 100 is 10. Square root of 81 is 9. We're going to factor to 10y plus 9 and 10y minus 9. Again, I encourage you to pause, work these on your own, and then double check with me. So this seems like it should be a difference of squares. The problem is with that x on the 36. 36 is a perfect square, but 36x is not. Kind of a weird thing. So all we have here is a common factor. And I think if you follow the idea of take out the common factor first, you would realize x is not a perfect square. So it just stops there. It's not that it does not factor, it just only factors with a common term. Alright, so number 7, we're looking at two numbers that multiply to be 4 but add to be 2. Our factors of 4 are 1 and 4, 2 and 2. Neither of these work. This is a does not factor. Be careful on the test if you're finding a lot of does not factor. It might just end up that you are not factoring it. It might actually factor. Number 8. It's tempting to try our AC method and multiply the 2 and the 50, but we notice that every term is divisible by 2. So we're going to factor out a 2 first. And this gives us a smaller trinomial to work with. In fact, it gives us a perfect square. Two numbers that multiply to be 25 but add to be 10 are 5 and 5. So this factors to 2a, square root of the first, use your sign, square root of the last, that's a 25 there. Quantity squared. Perfect square trinomial. Similarly to the last one, we're going to, all these we should always look for a common factor first. Everything is divisible by 3. So we get t squared minus 2, minus 2t plus 3. Now factors of 3 that add to be negative 2, it seems like it should work. It's very tempting to say that negative 3 plus 1, so let's use red because it's wrong. The problem with negative 3 plus 1 is that it doesn't multiply out to be positive 3. So because you need a negative 3 on the end for that to work, it means it does not work. So it's not DNF, it's just your factorization stops there. Don't put does not factor, it did have a common term. Okay, a little bit weird. Let's move on to number 10. Alright, so we've gotten out of the ones that are majority difference of squares and perfect squares, so we're going to use our AC method, and our AC method says multiply 3 times 8, and that gives us 24. All the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, The two that add to be 10 are 4 and 6. And this one's a bit tricky. Because there's a negative in the middle and a plus at the end. If you remember your rules, that tells us there's two negatives. But let's go ahead and write this out. 3x squared, two negatives down here, minus 4x minus 6x plus 8. Remember that 10x is now minus 4 minus 6, and that's an 8 on the end. So we're going to do two groups of 2. The first group is 3x squared minus 4x. The second group is negative 6x plus 8. When we take out of the first group, I'm going to take out a x. And I want a positive 3x and a minus 4. So to get that to be positive, to make that positive 6x, negative 6x a positive 3, I need to factor out a negative 2. Negative 6 divided by negative 2 gives me 3x. 8 divided by negative 2 gives me negative 4. Now we have a common parentheses of 3x minus 4. And the other parentheses is the leftovers, x minus 2. Alright, looking at 11, can I encourage you to pause and try these and start it back up when you finished it, see if you did the same thing I did. Here we notice that we have a 6 in front. We have no common term, so what we're going to have to do is multiply the 6 times the negative 15. So hopefully you used a calculator if you've tried this already, just to make sure you're getting it right. 6 times 15, negative 15 is negative 90. Factors of negative 90. There are a few. If you need to list them all, start with 1. It's even, so divide by 2. It's divisible by 3. If it's divisible by 2 and 3, ends in 0 is divisible by 5. We'll do that one first. 18. If it's divisible by 2 and 3, it's divisible by 6, which that's how we got there, right? 6 times 15. And the last one is 9 and 10. I've kind of actually seen this before, or something close to it. So you might have known pretty quickly it was 9 and 10. That's fine. I just wanted to show you the full list. So we're going to use 9 and 10, and we might run out of room here, so bear with me. Let's zoom in. So we'll write 6x squared. We want minus 9x, put the minus first if you can, plus 10x minus 15. Two groups of 2. First group, second group. In the first group, I'm going to take out a 3x. Gives me 2x minus 3. In the second group, I'm going to take out a 5. And that gives me 2x minus 3. Notice that the parentheses are the same, so the highlighted yellow are the same, so we're going to factor that out. And we get 2x minus 3 as our common factor. 3x plus 5 is the other factor. So these factors always go in, things that we factor out go in one of the parentheses. And there's your factorization for 11. Let's look at 12. We have a number, a is not 1, so we're going to find our master product. And let me get this out of the way. 2 times 3 is 6. What numbers multiply to be 6 and add to be 1? Well, it would be okay to subtract to be 6, but since 6 is positive, we need either 2 positives or 2 negatives. Neither work, so this is prime, or does not factor. Again, don't expect a lot of those on the test. Alright, I'm going to jump down to 13. We notice that it's a 4 in front, so it's not a 1x squared type of problem. We're going to find our master product. 4 times 5 is 20. That's our AC. All the factors of 20 are 1 and 20. It's even, so divide by 2. It's not divisible by 3, but it is divisible by 4. And since 4 and 5 are close together, that's all I can get. The two numbers that multiply to be 20 but add to be 12, hopefully you saw that, is 2 and 10. So we're going to rewrite this trinomial as 4r squared, and I'm going to put that 5 first. Though, yeah, probably shouldn't have. That's okay. Sorry. Plus 4r plus 5. So this is a trick that we learned, but we didn't like very much. Now in this first group, first set of 2, all I can take out is an r. In the second set of 2, there's no common term there. So let's take an r out of the first group. We get 4r plus 5. And what we notice is that if this parentheses is the same as what's left over, sometimes it's helpful to write a 1 out front. And you're not, I wouldn't say you're technically factoring out a 1, but we notice that the parentheses are the same. That 1 is useful when we make our second set of parentheses, and we'll get to that. So the first parentheses is the common parentheses. The second set is going to be r, but I need something else there, so that's where the plus 1 comes in, r plus 1. And that's your factorization. All right, 14. So we notice that it's 4 in front, 4p squared. We're going to multiply we're going to get our master product of 8. 1 and 8 is the first factor I choose, and in fact I can get negative 9 that way. If I add a negative 1 and a negative 8. So, this is a little bit harder with the 2 negatives, but we're going to write 4p squared minus r minus 8r plus 2. I've got 2 groups of 2. First group and second group. Notice there's a negative in that second group. First group I'm going to take out, where'd that r come from? First group I'm going to take out a p. Second group, notice that I need a negative, or I need a positive in front. This is a negative. That's going to be an issue for us. Because I want a positive 4p squared here, I need to factor out a negative. So I'm going to bring out a negative 2. And when I divide these by negative 2, negative 8 divided by negative 2 gives me positive 4p. Positive 2 divided by negative 2 gives me negative 1. And while I'm out of room, I think we can try to squeeze it in somewhere. We get 4p minus 1 and p minus 2. So that's 14. And we're about out of time. We will continue this with the third video.